What we're demonstrating in this video is Digit's ability to take unstructured voice input and turn that into a task that we can execute on the robot using large language models. The reason we're exploring this is because one of the most challenging parts of deploying a system like Digit, on top of all of the challenges of manipulating objects and moving around and navigating your environment and being safe, is actually the problem of specifying what it is that you want the robot to do. Oftentimes, teams of engineers are spending weeks, months, years describing what the actual task is that a robot needs to solve. And it can be a process that has to happen for each new task that a robot is being assigned to do. And that startup cost is a huge reason why a lot of types of automation and robotics ends up being deployed in one type of environment, but then doesn't get transferred over to another very similar type of environment. It's because you have to repeat all of that cost again. So one of the advantages of the Digit platform having such a human-centric design means that both the hardware can be moved really easily from application to application, but also a lot of the semantics of how to describe a task can be moved between environments and reused. The ways in which Digit manipulates the environment, the ways in which it thinks about the environment. So here we have a relatively simple task, which is to put all of the unpainted boxes in a bin and move the rest to the front row. There's a couple of things that are interesting, which is why we chose this particular prompt. One is that it's got multiple steps to it. It's not something the robot can do in a single interaction. The second, which really exemplifies the power of large language models, is it includes some form of semantic reasoning. Digit has to identify which of these boxes the unpainted ones are, which it can tell via its perception stack, but also it has to figure out a sequence that puts them in the bin and figure out where the remaining boxes can go in the front row. So there's a few different stages to the task that it has to reason over. And the LLM is great for interpreting that and figuring out sets of reasonable actions that the robot can take based on its capabilities that might match up to executing this task. The purpose of exploring this is a toy task right now, just moving boxes around in towers, but it's really similar to some of the tasks that Digit might do in a warehouse or logistics facility, where we might be moving bins to different locations based on some sort of logic about them, like what zip code they're destined for, or what types of items that they hold. And instead of humans having to write all of that logic out in code or in block diagrams or in process flows, we can speak a natural language description of that task and use large language models to fill in the blanks about how to turn that into sets of actions that the robot can do. And that has the potential to greatly ease the cost of bringing Digit into a new application.